In this video, we are going to learn how to calculate R. And I'm going to teach you a way of calculating it that makes it a lot easier than how the book shows. So there is a formula in the book, and it is also, I'm thinking, the formula that it's going to show you when you do it on Connect Math. If you hit Show Example on Connect Math. The way that I do it is it breaks it down into three kind of bite-sized pieces, and those pieces are very, very familiar pieces since you've already been calculating the standard deviation. And it just makes it real simple. So you might want to stick with this method as opposed to trying the other methods. Of course, when you come to the test, you just got to be able to calculate it. So if you're getting the right answer, it's not right or wrong. It's just that this is a lot easier. So basically, the way that we're going to calculate it here is that R is just going to equal something called SSXY divided by the square root of SSX times SSY. And this is where each of these SS's are equal to the following, where SSX is just equal to the sum of x squared minus the sum of x quantity squared over n. So that should look really familiar because that is the computation formula for the numerator in the standard deviation. So if you were doing the standard deviation, you would just divide that by n minus 1, take the square root. Okay? So very familiar at this point. Well, the SSY is actually the same calculation, but you do it with the numbers in the y column. So it would be sum of y squared minus the sum of y quantity squared over n. Pretty much the same thing, just the notation is changing because you're doing it with the y values. And then this one is the one that's maybe a little different here. It's kind of doing this calculation with both x and y at the same time. So we call it SSXY. And this will be the sum of x times y minus the sum of x times the sum of y over n. So you're going to use these formulas to calculate those three numbers. You're going to put it in here, and then you're going to get the final answer. Okay? So let me give you an example here. So I'm going to give you an x and a y coordinate. So let's say we have 1, 6, 4, 3, 7, 1, and 8, 2. Okay, so when you do these, that first column is always the x coordinate, the second column is the y coordinate. That would be true with this example that we started out with, like the hours worked, that would be your x, and the GPA, that would be your y. One thing here is that let me get a sheet of scratch paper here. If you're doing it on the computer, they're going to write this like this. So they're going to have the column horizontal. The top one are your x values. The bottom one are your y values. This is the same as this, except the x values is the first column. The y values are the second column. Okay? So now what you have to do is you have to get all these different sums. Okay? A lot of these are familiar. The only one you haven't seen before is this sum of x times y. So here's how I would do it here. If you're going to find these sums by hand, what you're going to see is you can actually calculate the sums on the calculator, and we'll have some videos about that later. If you're going to do it by hand, I would extend this column or this table out to include 3 more columns. And one would be x squared, all the x squares, which are the square of the x values. This column would be the square of the y values. And then the xy for this sum of x times y. What this is it's the x coordinate times the y coordinate for each of those. Okay, so for the x squared, I'm squaring each one of these, so I'd get 1, 16, 49, and 64, like that. So for the y squares, this would be 36, 9, 1, and 4. And then for x times y, I'd be taking 1 times 6, which is 6, 4 times 3 is 12, 7 times 1 is 7, and 8 times 2 is 16. And then what you're going to do is you are going to total each of these, and when you do that, you are going to get, and I have it here on another sheet of paper, when you total these you get 20, and then when you add these up you get 12. If you add these up you get 130. Adding up the y squares gives you 50, and then adding up the x times y gives you 41. Now what I would like to do here is just write what sums I just got. And you wouldn't have to write these out. Once you understand the table, you could just get the numbers from here. But this column here, the total you got there was the sum of x. And then the sum of y would be the sum of this column, so that would be 12. This would be the sum of x squared, which is 130. And then this would be the sum of y squared, which is 50. And then the sum of x times y is this column here, which is 41. And the one thing that we don't have here that we need for these formulas is n. And so n is just the number of ordered pairs, or the number of rows in the table. So in this case, n is 4. Okay? And so now we have everything for these formulas. So SSX, this is just like doing the standard deviation for these x values, right? The numerator. So you have sum of x times y is 130, and then you subtract the sum of x, that quantity squared, divided by n, and n is 4. Okay, so I'm going to put these in my calculator. So I'd get 130 minus 20 squared divided by 4, and this is going to be 30. Okay, and so if you were doing the standard deviation, you would then divide that by 3 and then take the square root. So you're just, this is the formula for getting that numerator. Okay, so there's really nothing new about this. And nothing new about this, you're just doing it now with the y values, right? So you're going to take the sum of y squared minus the sum of y, which is 12 squared, over 4. And I get 50 minus 12 squared divided by 4. And I get, for this one, I get 14. Okay, and now the sum of x times y. So SSXY. So this is where the sum of x times y comes in, this last column, and that'll be 41. And then what you do is you take the sum of x times the sum of y. So that would be the 20 times the 12, and that divided by 4. Okay, so 41 minus 20 times 12 divided by 4. And you can put that in there without parentheses. You'll get it. You could use parentheses, but you don't need it. And so this is negative 19. Now what I want you to notice is that both of these are positive. Okay? And so these will always be positive, just like when you calculate the standard deviation. Okay? So if you get one of the either the SSX or the SSY to be negative, then you made some mistake, maybe in adding or something else. Okay? They should be positive. And it makes sense here too, because if you had a negative underneath the radical, you can't do that. You can't take the square root of a negative number. Now the SSXY, this will be excuse me, positive or negative depending on the type of correlation. And so what I mean by that is if this original XY, if this has if these ordered pairs have a negative correlation, this better be negative. And in this case it is negative. Here, as these increase, in general these are going down. And so if these have a positive correlation, this should be positive. And in fact, that sign is what's going to go up here. It's what's going to give R either a negative value or a positive value. Okay, so now what you're doing is you're putting these three into this formula to get R. So the top is negative 19, and then the bottom here you're taking the square root of, in this case, 30 times 14. Like that. And so now when you put this in the calculator here, so negative 19 divided by, it's important that you have a parentheses around the 30 times 40, because you want it to multiply first before it takes the square root. Like that. So you got to have the parentheses here so that it'll multiply first and then take the square root. Without that, it would take the square root of just the 30 and then multiply, everything by, it'll take the square root of 30, divide 19 by the square root of 30, and multiply the whole thing by 40. It won't be right. You got to have the parentheses just like that. And then when I do, oh, that's actually wrong. That should be 14. I'm like, that's not right. This has a stronger correlation. So this should have been 14. So I just put it in wrong. So click equals, and there we go. So what is my R? It's negative 0.927. And what you're going to do is you're going to round these to 3 decimal places. And the reason for that is we're going to learn a hypothesis test that's going to use the sample data to test whether there's a correlation in the entire population. And the values that you compare this to have 3 decimal places. So you're going to go ahead and round your R to 3 decimal places. So that's R there, and you can see that this is a fairly strong R, isn't it? That is fairly strong, and so this is a pretty strong negative correlation because that's pretty close to -1. Okay, and so that's another thing. If this thing isn't between -1 and 1, if it's like bigger than 1, then you know something's wrong. You need to go back and fix that. So let me go ahead and I'm going to actually make the scatter plot here to see if that R makes sense. So 1, 2, 3, 4, 5, 6, 7, 8. This needs to go up to 6. One, 2, 3, 4, 5, 6. And so 1, 6 would be an ordered pair here. 4, 3 would be like right there. 7, 1 would be right here. And then 8, 2 would be right there. And indeed, this has a fairly strong negative correlation. They lie along a line there pretty strongly. And so our R is close to -1. So there you go. That's how you calculate R, and you're going to get a number between -1 and 1, and it's going to measure the strength and the direction of the linear correlation that's between the variables. So in the next video, I'll put up another example, and I'll give you a chance to try this, and that way you can get some practice with this. One other thing is the numbers here I chose were all fairly small, and there wasn't a lot of them, and so it was quick, easy to get the sums and put them in here, and that's great for getting practice. But a lot of the ones on the homework, you're going to have more numbers, and they're not going to be as nice and simple as single-digit numbers like this. And so getting all these sums is a lot of work, and you can get error in there pretty easy. So we're going to have a video of how you can use technology like your calculator in order to get these sums, and you're going to probably want to do it that way as you're working on the homework. I won't have that video up until sometime on Monday, but the homework for this isn't due until I think it's Thursday night. And so what you can do is, if you have a calculator, what you'll want to do is, if you want to find a video on YouTube, just type in the name of your calculator and then write, how do I do two variable stat? So if you have like TI-30, how do I do two variables, an X and a Y, stats or statistics. And you could have, how do I do two variable statistics on a TI-30 or on a Casio FX 300 MS or whatever. It'll show you how to put in the data, and then you can get these sums on the calculator, just like you do for standard deviation, one variable stat. And in fact, you could probably almost figure it out because you have to select one variable stat, and then there's two variable stat. And so you play around with it, you can probably even figure it out yourself, but there's probably tons of videos on YouTube about that. So, okay, but for this one, the example I'm going to give is going to be fairly small numbers like this again, and so you can just give it a try, okay? And you can do it by hand here.